recording. Okay, and now let me switch my screen. So let's see. We are here. Okay, so if you go to Blackboard, as you can see my screen here, if you go to midterm exams, I have this mock quiz, which is not a real quiz, but it's worth 5 points if you do it. And here's the instruction. This is a mock quiz to see if you can answer, what, 2 questions on each page, and then what, convert it to PDF and upload it as a single file. So if you click on mock quiz, notice I have 2 silly questions for you. What's the date today? And when is our first midterm? The idea is just to make sure you know how to do this. So next Thursday, when we have tests at 7 o'clock, so you know how to do this, so you won't run into any technical issue, okay? And incidentally, so if you just click on mock quiz, the title, so notice it says 5 points, and then you can what? Attach your file, and up here, I don't know if you guys can see it. Up here, notice it says submit. Then you can submit it, then I can see your submission. So that's the idea behind the mock quiz, to see if everyone knows how to do this. Where on the Blackboard can I find the mock quiz? Right here on midterm exams. Midterm exams. Okay, so once you click on the file, it opens. Answer the silly questions which I have on each page, but remember you're supposed to convert it to PDF as a single and upload it on the Blackboard. Now let me for 1 sec switch the screen here, show you what I have on my iPhone. Notice I have this program, I'm sure you all know, it's called Cam Scanner. So when you click on it, it's free by the way. So it's called Cam Scanner. Notice you have the camera. So what you do, you click on the camera. So now it's gonna take a picture, but instead of single page, go to batch and what? Take multi-pages, you know, 2, 3, 4 pages at a time. Do not go to single, go to batch, and then once you're done, it will automatically convert what? The file to what? To PDF, and then you can kind of go from there, and then you can upload it. Let me just take a picture for fun of it. Here's 1, here is 2. Okay, I'm done. So now I'm gonna go, okay. Come on, what's going on here? Okay, there it is. Okay, there are the pages. And now you can what? Upload it. You see where it says share? Notice it's a single file, but it's 2 pages. And it's free. It's called Cam Scanner. Let me see what we got on there. There is an app called, yes, I know that too, yes. Yeah, Tiny Scanner. I just happened to download this on my iPhone. And this is for those of us who don't have access to printer, so you can do this. Like for instance, on next Thursday when you take a test, take a clean piece of paper, put your name on top, and what? Number 1, here's the solution. Then number 2, here's the solution. Box your answer, take a picture, scan it, okay? And then using this app or Tiny Scanner, then you can upload it on what? On Blackboard. And I can, the reason I want it in PDF format, so I can correct it by using my iPad. So I can correct it on the screen, and put some comments and then upload it back onto a Blackboard so you guys can see if, God forbid, you made any mistake, what was the mistake and what's the correct way. So that makes my job easier. That's why I insist that you don't send a picture, but send a PDF format, okay? So that's one thing I had to mention. The other thing which I like to mention is, let's go back to the Blackboard. We see where is right here, it says review problems. Do you see it? It's not due tonight. It's somewhere, sometimes between now and let's say Wednesday night, you can do it. So you don't have to do it tonight, but if you do, more power to you. Anyways, if you go to review problems on Blackboard, notice I have posted some review problems here. So if you open that, you get this. Okay, there are about, I would say 20 problems. I have given some hints how to do it, but I didn't do it, the problems. These are just hints how to do it, okay? And some of them I just gave you the answers. Here is the deal. If you do these problems and what? Turn these problems the night of the test, and upload it. So I will create a file called extra credit problems. You will earn 10 points. Okay, so if you do these problems completely, you will earn 10 points, which does two good things for you. One, you get 10 points. The other one is it should, kind of prepares you for upcoming tests because the tests will be very much similar to these problems. I will just look at these problems and change the numbers around a little so it won't look exactly the same type of problems, but it will be like these problems. Do you see it? Of course, we won't have 20 problems on the test. Chances are we will have like half of it. So you will have time from, let's say, 7 to, let me ask you this. Does anyone have any class after this class? Yeah?
No.
No, so you will have 2 hours to do this. How about if we go from 7 to 9, and then 9 o'clock would be the deadline. So you're supposed to by then upload your solutions because the site, the Blackboard, then won't accept any late submission. So how about if we go from 7 to 9, so that gives you 2 full hours to take the test and submit it on what? Blackboard. So this, if you do it, it's optional. If you do it, you get 10 points. If you don't do it, at least take a look at the problems. Make sure you know how to do it. If there is any question about any of these problems, I will answer your questions on Tuesday, okay? Because I want to first give you a chance so you guys can see, try it, see if you can do it. If not, then come back on Tuesday. I'll answer your questions. Hopefully you'll have a complete solution by Wednesday night. And then when you submit it, you will have what? You will get 10 points. Okay, so this is due tonight. What is due tonight, Judy? What's due tonight? This right here, the extra credit problems. Extra credit problems are due, if you want to call these extra credit problems, next Wednesday. That means, excuse me, next Thursday, which is what? The night of the test. So before you take the test, please submit your extra credits on Blackboard and then start the test. The mock quiz, which I have it here, this is due by Wednesday night, next Wednesday, because I want to make sure that you guys know how to do this. Because after the test, what difference does it make? This is not you know, I'm gonna give 5 points for doing this. I just want to make sure you guys won't run into any technical problem the night of the test. Okay, anything else? We good? So do you all see where things are located? Oh, one more thing, and that's like if you go to course content, remember I have these modules, you see it? Like for tonight, notice I have a table called Annihilator table. So if you could just print this because we need this table to do section 4.4. Also, I have, you see where it says lecture video link? These are the what? A link to the live lectures which we have every Tuesday, Thursday during the class time. So if you click on it, it will take you to, hopefully, to the video. Like this is from last Tuesday. Notice there is a date. You see that? There is a date, 9/8/20. Okay, so that's where you can find the live lecture videos right here under the modules for each week. So tonight, when I record this, when the class is over, I'm gonna what? Have a second link here. So that will, this is for Tuesday. For tonight, I'm gonna attach that link over here as well. Do you all see it? So we good? Everyone happy? Any questions? Yeah, we are okay? All right. So also the homework assignment is due, what, Sunday, this Sunday, a minute before midnight. So if you haven't done the homework, I hope you have done it, so far some of it at least. So please make sure you complete it because you will take a test next Thursday. So if you don't do homework, it'll be hard to take a test because you won't have enough practice to take the test and finish it on time. So that's basically what that guy was about. So are we okay? So should we start doing some problems? Please let me know if you have any question. I have the chat here open. So if you have any comments, questions, please let me know. Suppose we have this third order linear homogeneous differential equation, this guy. Okay.
Professor,
Yes, please.
the main cam is not seeing the paper. It's you.
Oh, I'm sorry. Jesus, sorry. Thank you. Can you see it now?
Yes, thank you.
No, I am so sorry. I completely forgot. Thank you. And also, am I recording? Yes, I am. Yes. Okay. So this is third order linear homogeneous differential equation with constant coefficients. These are called coefficients. They are constants because we do have type of equations where the coefficients are no longer constant. So the question is, how do you handle those guys? Also tonight, we will see what happens if the equation is non-homogeneous. What if I have a function of x here? Now what? So because this is homogeneous, these are relatively easy equations to solve. So immediately by inspection, why don't you see what the auxiliary polynomial is equal to? Auxiliary polynomial is r cubed minus 2r squared minus 4r plus 8. Notice I replaced this guy with, notice the solution of these guys is in this form. It's an exponential function. So when you take 3 derivatives of this guy and substitute here, you would end up with what? Something like e to the r x times r cubed minus 2r squared minus 4r plus 8 is equal to 0. This guy cannot be 0 because exponential functions, no matter what x is never 0. So you would end up with setting this expression equal to 0. That expression has a name. It's called auxiliary polynomial. whose roots happens to be what? Enables us to write the solution, correct? So let's see if we can set this guy equal to 0 and solve for r. If you remember from algebra classes, this is called four-term polynomial. And the way we factor these kind of polynomials is 2 at a time, correct? So the first two factor out r squared, and the last two factor out negative r, so you get this. Do you all see it? Now, from these two guys, factor out r minus 2, correct? And what would that leave you inside the second parentheses? That would leave you with r squared minus 4. Is that right? But this guy is difference of 2 squared. That guy factors at r minus 2, r plus 2. Notice I'm going to get 3 roots, and that makes sense because the degree of the polynomial was 3. So I got to have that many answers. So if you set each of these guys equal to 0, looks like you have r is equal to 2 with, remember we call this multiplicity 2. Multiplicity means multiple copy of the same answer. Either you write r is equal to 2 twice, or write it once, but say multiplicity 2. On the other hand, r is equal to negative 2 if you set this guy equal to 0 with multiplicity 1. That means we only have one copy of this guy. Show the fundamental solutions. This guy is easy. It's e to the negative 2x. Remember, the solution is supposed to look like this, e to the power of rx. So what about these guys? Remember, we talked about this. That's repeated. So one of them is e to the x, the other one is x e to the x. Remember, that was the deal which we saw this last time. When you have real repeated roots, what? Then you would have the factor of x. But that's not the answer. The final answer is what? Rain or shine. So these are called fundamental solutions. And remember, fundamental solutions, they're supposed to satisfy 3 conditions. What were the conditions? Each of these guys should satisfy the original equation. So each solution should what? Satisfy what? The ODE, that's one condition. The other condition is what? Functions, what? Should be linearly independent, which I haven't shown you how to do linear independency when you have more than 2 functions. Because if you have 2 functions, you just take the ratio, make sure the ratio doesn't come up as a constant. But when you got 3, ratio doesn't work. But let's say these are linearly independent, and the number of solutions should match the order of what? ODE. So these are 3 conditions for bunch of functions to form a fundamental solutions. Each solution should satisfy the original equation. They cannot be combinable. You cannot combine any of these. And the number of solutions must match the order of differential equation. Notice the order was 3, so I came up with 3 fundamental solutions. So the final answer is linear combination of these guys. What does that mean? Multiply this by a scalar, multiply this guy by a different scalar, multiply this guy by a different scalar like c, and add the answers up. This is called linear combination. So now this is the final answer, which is our so-called general solution. Do you all see it? Yeah? So notice one more thing, please make a note. General solution, y sub g stands for general solution, has 3 constants. Linearly independent constants. So notice the number of constants also should match the order of differential equation. And you should not be able to combine the C's. They should be also linearly independent. In other words, there is no way I can combine C1 with C2. It's just not going to happen. You see it. So the number of solutions, the number of C's should match the order of differential equation. This is called general. If they want me to find the C's, they have to give me initial conditions. How many initial conditions does it take to find C1, C2, C3, guys? How many initial conditions they should give me? Okay. Anyone? What should be the number of what? Initial conditions. How many conditions do I need? Yes, 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 yes. Thank you. I saw your response. Yes, thank you, guys. Also, last time, I don't know if I did it. I think I did it, but I'm not sure. The question is, when you solve the auxiliary polynomial, which comes up, let's say we're dealing with second order, what was it? Differential equation. And what? Auxiliary polynomial gave you, let's say, complex solutions. So these are called complex roots. Is that right? This is like section, what was it? 4.4. Did we go over this, guys? What happens when the roots of the auxiliary polynomial is complex? Did we do that? Can I have a thumbs up or down? Yes, no. I think we did. Oh, okay. Thank you, Pedro. All right then, so there it is. So this is like when you solve for R. When you solve for R, you get minus b plus or minus the square root of b squared minus 4ac over 2a. This is the case when what? B squared minus 4ac is less than 0. If the stuff under the radical, incidentally, this is called discriminant, is less than 0, you can bet your money you're going to come up with complex what? Roots. I think I showed you about Euler's formula. I think cosine of theta plus I sine theta and all that good stuff. Then it took about a page or so. At the end of the day, I told you guys, I came up with e to the ax cosine of bx and e to the ax, what? Sine of bx happens to be your fundamental real solutions. Notice in your final solutions, you should absolutely have no I in it because the ordinary differential equation will be in terms of a real function, like let's say a y double prime of x, b y prime of x, c y of x equals 0. But remember, y of x is a real value function. So if the differential equation is real, how am I supposed to expect the solutions be complex? So the solutions have to be real as well. So these are called real fundamental solutions, correct? And this scenario, this format always holds true. So where did I pull the AB from? From the roots of the polynomial. Notice this is like the real part. This is like the imaginary part. So the plus will give you cosine, the minus gives you sine. In other words, what I'm saying is, suppose you have y double prime plus 4y is equal to 0. Question is, solve. Okay, so how would you solve this? Well, let's see now, what is the auxiliary polynomial? Auxiliary polynomial is r squared plus 4 is equal to 0. Okay, there is no need for quadratic formula. You just move the 4 over. Now it becomes negative 4, but the minute you take the square root of negative 4, you know you're going to end up with what? Complex or imaginary number. So what's the answer? The answer is plus or minus 2i. which I can rewrite this as 0 plus or minus 2i. Why did I put a 0? Just to emphasize my a is 0, my b is 2. Because off of my complex roots, one of the things which I have to extract from here is identify what a and b is so I can form these functions. So in my case, the fundamental solution is e to the power of 0x cosine of 2x and e to the 0x sine of 2x. Do you see it? But e to the 0 is 1, so these guys go to Neverland, right? So the general solution, y sub g, is a linear combination of what I have inside the braces, which is what? C1 cosine of 2x plus C2 sine of 2x. Ladies and gentlemen, this is my final answer. Final answer. Okay? Sometimes, like last semester in the class, somebody left this as a final answer. That's not an answer. That's just fundamental solutions. You need to now, I need to now take the what? Linear combination of this, set it equal to y. So this function, yes, each of these guys are solutions, but so is the linear combination of them. Okay, so therefore this is your final answer, and that's what you box. In case they were interested to know what C1, C2 is, they need to give me what? Two initial conditions so I can find C1, C2. Otherwise, if there is no initial condition, this is the final answer. Do you all see it? We good?
Professor,
Yes.
um, for the exam, can we not write the fundamental solution and then just write the
You
answer?
don't have to. You can go from here to here.
Okay,
You
thank you.
got it. No problem. No problem. Okay then. So that's basically what that section was all about, except I'm trying to look for more example so I can show you guys. And now let's see if I can show you this example right here. Suppose, just suppose the problem is solve. Okay, solve. We'll solve what? Y double prime plus 2y prime plus 2y is equal to 0. Okay, there you have it. So now, auxiliary polynomial, you can write this by inspection. What is the auxiliary polynomial? R squared plus 2r plus 2. Notice the y factor doesn't have an r in it. Okay, so factor this out. It's not factorable, so you use quadratic formula. What is it? Minus 2 plus or minus square root of 4 minus 4 times 2 over 2 times 1. Why? A is 1, B is 2, C is 2 in quadratic formula. Do you see it? So now, what? We get r is equal to minus 2 plus or minus 4 minus 8 over 2, which is minus 2 plus or minus square root of negative 4 over 2, which is negative 2 plus or minus 2i. You know why I, don't you? Because this is square root of negative 4. I can write that as square root of negative 1 times 4. But I can split the radical, write it as the square root of negative 1 times the square root of 4. But by definition, this is I. That guy is 2, so I get 2i. Do you see it? Over 2. But now I can divide top and bottom by 2, get negative 1 plus or minus I. So simplify the fraction. Reduce the fraction to its lowest term. And get what? Plus or minus negative 1 plus or minus I. So looks to me, A is negative 1, B is 1. Don't worry about the plus or minus, because I'm comparing this to r is equal to a plus or minus bi. So fundamental solutions happens to be what? So someone said, can I skip this fundamental solution? Yes, you may. I'm just showing it to you so you guys can see where I'm pulling the solution. But if you really don't like that step, then jump into the solution. What is it? C1 e to the power of negative x cosine of 1x, C2 e to the negative x sine of 1x. There is no need to say 1x, just say cosine of x and what? Sine of x, box the answer. You are done with that problem. Do you see it? Question on this, guys? Yes, are we okay? Is it possible that we may have repeated complex roots? Oh, yes. How? Suppose you got fourth root of x plus 2 fourth derivative of y of x plus 2 times second derivative of y plus what? Y is equal to 0. This is fourth order. I need 4 solutions. So auxiliary polynomial is r to the 4 plus 2r squared plus 1. There is a 1 here you don't see. Set this equal to 0, solve for r. Okay, find r. You need four answers for r because this is 4th degree. Factor this, r squared plus 1, r squared plus 1. Set each of these guys equal to 0, solve for r. So this guy gives you plus or minus I, this guy gives you plus or minus I. So what does that tell us? That tells us r is equal to negative I multiplicity 2, so is positive I multiplicity 2. Okay? Remember, each of these guys is 0 plus or minus I, meaning this is 0 plus I and then 0 minus I, but each of them are repeated. So what would be the solution? The fundamental solutions. E to the 0x cosine of x, e to the 0x sine of x. But remember, these are repeated. So the next one is x e to the what? 0x cosine of x, x e to the 0x sine of x. There. So the final answer is C1 cosine of x because e to the zeros, they happen to be all 1, plus what? C2 sine of x plus C3x cosine of x plus C4x sine of x. Notice, as I promised, the number of C's in your final answer should match the order of differential equation. Because it was 4, so you gotta have what? 4 C's, and they should not be combinable. And we should have what? 4 fundamental solutions. Do you see it? And they should be linearly independent. That means there is no way I can combine any of these guys. They're not combinable. Okay? Do you see it? Are we good with that? Yes? We okay? Question arises when you have what? A function on the right side. So the question is, this is like 4.4. I don't know if we're going to finish this. I hope. So if we don't finish it, then we have to think about it. So let me see how far we can get into this. Question is, you still have what? Constant coefficients. Let's start with second order. So far, so good, right? But instead of 0, what if I have a function of x here? Now what? If that's the case, this is called second order linear non-homogeneous, because I'm assuming this function is not equal to 0, non-homogeneous ODE with what? Constant coefficients. So what does that mean? That means A, B, C are numbers, are constants. Okay, now what? To do these kind of problems, I need to back up and kind of define few items so we can come back and solve these guys. One of them is called differential operator. Okay, it's not a function, it's an operator. It's denoted by capital D, which means derivative of something, but it doesn't say derivative of what. Okay, so what that means is if I have D squared, that means second derivative of somebody. So these are blank derivatives. They are known as differential operators or operator. So if I have D to the n, that means the nth derivative of somebody. So what does that mean? That means if I have D of y of x, can you tell what that means? What is D of y of x? You want to take a wild guess on that? D attached to y of x. What do you think that means? Wild guess. Yeah, this means dy dx. But that doesn't mean dy dx. That's just the derivative of this is blank derivative. This is an operator. But the minute it's applied to a function, now you have dy dx. Similarly, what if I have d squared y? That means what? Second derivative of y with respect to x, and so on and so forth. So the question is, why do I care? Well, sometimes a y double prime of x plus b y prime of x plus c y of x equals f of x. Not this, any differential equation can be written in operator form. So the operator form for this guy would be d squared plus d plus, let's say this is ad squared plus bd plus what? C applied to y of x equals f of x. There it is. So what does this say? This says a times second derivative of y plus b times first derivative of y plus c times y itself. So we call this what? Differential operator polynomial. So this is differential what? Polynomial. Polynomial. Can you set that equal to 0? No, because it doesn't make sense. These are just the happy faces. These are just notations. You cannot set this equal to 0. But you could set the auxiliary polynomial equal to 0 and solve for r, because r is a real number. But here, d is an operator. What is an operator? It has to apply to something to make sense. For instance, sine is an operator. But if you don't apply it to any angle, it doesn't mean anything. Unless you apply it to an angle, then it means something. Okay? Log is an operator. It's just a symbol. It's an operator. Unless you apply it to a number, then it means something, right? So is D. Is differential operator by itself, it doesn't mean anything. Unless it's applied to a what? Function, then it means derivative of that function, depending on the superscript here. So what that means if I have an equation like y double prime minus y prime minus, let's say, oh, I don't know, 6y is equal to 0, how would I rewrite this? How would I rewrite this in D operator form? How would I do that? How would it look like? Did you want to give it a try? I want to what? Change this to a D operator. Yeah? Anyone cares to tell us how would I rewrite this way? Yes? Ready? Did you want to say it as opposed to type it? Just say it. Yes? I'm ready.
D squared y over dx.
Wait. D squared y? There is no y inside.
Oh, I'm sorry. I was looking at the wrong one.
Okay. D squared.
Okay. Oh, never mind.
Never mind.
Minus
Minus D minus 6, close the parentheses, y of x equals 0. There it is. This is your what? Differential operator. P of D is equal to D squared minus D minus 6. Okay? So immediately you can tell off of P of D what's P of R is. It looks just like P of D, except you are allowed to what? Set this guy equal to 0, but you cannot set this guy as equal to 0. Not okay, because these are operators. This is a polynomial of real numbers. You know, when you set this equal to 0, it is just like what? You setting bunch of happy faces equal to 0. What does that mean? I don't know. It doesn't mean anything. So you can never set this guy equal to 0. But associated with any what is that? Differential polynomial, there is auxiliary polynomial. So this guy is called differential polynomial. This guy is called auxiliary polynomial. The difference, you can set this guy equal to 0, but not this guy. Okay, so what? Well, so we could what? Do this kind of equations now. So now I can give you equations in D operator form, like let's say, you ready? Let's say you got, let's say you got y double prime minus, sorry guys, let me find the problem here. Just one sec, I'm trying to find the problem.
Professor, it's not clear.
Oh, yeah. Oh, sorry. Let me go back, make sure it's clear. Is it, let's see, is it clear now? Yes?
Yes.
Oh, great. So, the idea is this. What? Y double prime plus by prime plus cy of x is equal to, what was it? F of x. So these are non-homogeneous differential equation. Let's start with second order, then we can what? Raise the order to whatever the order our heart desires. But let's start with second. Okay, so so the idea is, wouldn't it be nice somehow I change what? Equation number 1, which is non-homogeneous, into homogeneous kind. Wouldn't it be nice? I could do that. How would I do that? That's where we need to know a differential operator. So this is not an auxiliary operator, it's a differential operator, okay, known as annihilator. Annihilator. Okay, sounds like Arnold's movie. Annihilator, destroyer. And it's denoted by Q of D. Q of D. What is the job of this annihilator, which is a differential operator? So that's the definition of what is known as annihilator. Guess what that guy is going to annihilate? You know, annihilate means it's going to wipe out something, right? It's going to wipe out something. What do you think is going to wipe out? Dysfunction. In other words, I'm looking for a what? Differential operator. When I apply it to f of x, I get 0. So that way I can change my non-homogeneous equation to homogeneous, get part of my solution, then I can find the remaining solution easily. But the first part is, how do I get rid of this guy? So the question is, how do you find this operator? Let's do an example to see how this is done. Suppose your f of x is, let's say, e to the power of 3x. I need an operator, differential operator, which I am trying to find it, such that whatever that guy is, the minute I apply it to e to the 3x, it changes the function to 0. What would that be? Well, let's give it a try to this operator, d minus 3. Let's see if this does the job. Let's see. Okay, let's test drive this. Test drive this operator. See if it works. So I'm going to take d minus 3 and apply it to e to the power of 3x. Is that right? So, so what does that mean? This says take the derivative of e to the 3x, which is 3e to the 3x, and then multiply e to the 3x by negative 3. There. Ta-da! 0. So the conclusion is what? The annihilator for what? For e to the 3x is d minus 3. Question, what if this guy had a coefficient like, let's say, negative 16 e to the power of 3x? Would that negative 16 put any dent on the annihilator? What do you think? You want to take a wild guess? Would that put any dent in the final answer? Yeah, answer, no, this is still d minus 3. So this coefficient is irrelevant. It doesn't put any dent in your what? Differential operator. You don't believe it? Go ahead. Go ahead and apply d minus 3 to minus 16 e to the power of 3x. The derivative of this guy is 48 e to the 3x. Is that right? Minus 3x. Am I right here, guys? And then, where am I? What happened here? D minus 3, right? Where am I? What happened? So the derivative is what?
To negative 16 e to the negative 3x, but it was only positive 3x.
Oh, yeah, Jesus. Thank you so much. So, so that would be negative 48 e to the 3x, and this would be positive 48 e to the 3x, ta-da, 0. So this negative 16 was irrelevant, wasn't it? So with that in mind, the question is, hey, how did you get this? Yeah, it works, but how did you get it? Well, the answer is I have this table, which is called annihilator table, annihilators. There they are. So it turns out if you have e to the x, or x times e to the x, or x to the k e to the x, the annihilator is d minus a to the power of k minus 1. So you want to have this handy when you're doing what? Problems in section 4.4. You need this table next to you so you can find the annihilator. And then you can go from there. That's our first step. Then the question is, what if I have a polynomial? No exponential. Answer, the annihilator is d to the power of k plus 1. Let me just zoom this. K is the highest power, is the degree of your polynomial. So the annihilator is d to the power of k plus 1. Okay. By the way, this guy annihilates all of these and linear combination of those. This guy annihilates e to the ax cosine bx, e to the ax sine bx, or any combination of these two guys. This is your annihilator. If you add a factor of x to these guys, such as these guys, x squared, x to the k, then your annihilator is the same as before, except you have to raise it to k plus 1. So I hope you have this handy. If not, is there any way you can print this in 2 minutes so we can kind of get this going? Because I like to show you how to find annihilator for certain functions here and then go from there. So does everyone have that table handy by any chance? If not, I will show you my table so you guys can help me out here. So question is, find the annihilator for these guys. Let me see, what do I have on the chat? This week course contact, yes, in the course content under the module for this week, which is September what, 8 through 10, I think you should have a copy of the what, the table, the file attached. You should have a link. Okay, so here we go. Let me just show you mine so you guys can find yours. Let's do number 2, then I can go back to number 1. Number 2, remember the coefficient is irrelevant. It looks like this guy. Can you see it? Let me just zoom in. It looks like this, doesn't it? So the coefficient of x at the exponent is my a. So the annihilator is d minus a to the power of k plus 1, provided you have x attached to the e to the x. I don't. So in other words, this guy is 5x to the 0 e to the negative 3x. Okay, so this guy is my k, this guy is my a. So my annihilator is d minus a to the power of k plus 1. So my annihilator, q of d, is d minus 3 to the power of what? 0 plus 1. So therefore the answer is d plus 3. That's my annihilator for what? For 5 times e to the negative 3x. Do you see it? Okay, let me zoom back so you guys can see problem number 1. This guy was a single term, So I came up with a single operator. This guy is not single, it's combination of two separate functions, correct? So what does that mean? That means I need to find two annihilators, one for each, correct? One for each. Is that right? What is the annihilator for 2 times e to the x from this table using formula number 1? Can you tell? Excuse me. Yes. Sorry?
D minus 1.
1, because the coefficient is 1, and that is your A. Good. What is the annihilator for 3x? 3x is kind of like this polynomial. And the annihilator is d to the power of k plus 1. K is the highest power of x in your polynomial. In my case, the highest power is 1. So according to this note, right below formula number 1, the annihilator is d to the power of k plus 1. So what would be the annihilator for this?
D square.
D squared. And that makes sense. You take 2 derivative of negative 3x, it changes to 0, doesn't it? But what do I do with these guys? So what's the final answer for the whole expression, for the entire function? Is not the summation of the operators, but it is multiplication of the operators. Notice, once you find the annihilator for each term, do not add or subtract, multiply. Excuse me. What does that mean? That means the final answer for this problem is d squared times d minus 1. There goes my final answer. But to get there, I had to find the annihilator for each function and then multiply the answers. Notice, you do not add or subtract, you multiply. So, multiply, do not add or subtract. Next, once again, I have combination of two functions. I need to find 2 annihilators, one for each, then I can multiply. So my final answer should look like q of 1d times q of 2d. The question is, what are the annihilators for these guys? Well, let's see now. Let's see. The first one is x cubed e to the power of 7x. That kind of falls into this category, x to the k e to the ax. So comparing this format to what I have, it looks like k is 3, a is 7. So if k is 3, a is 7, the annihilator is d minus a to the power of k plus 1, because here is the form of the function I'm given. So this is the annihilator for these kind of functions which they have this looks. So what would be the annihilator for the first one? What is my q1d? Is d minus 7 to the power of what? K plus 1. So it's d minus 7 to the power of 4. That's for this guy. What about this guy? It has a sign in it. Well, I can no longer use formula number 1. I have to use formula number 2, because formula number 2 has a sine and cosine in it. Okay, but first, before I use this annihilator, I have to identify what is a, which is the coefficient of x for exponential function, and what is b, which is the what? Scalar times the angle. So this is like something times x. The whole thing here is theta. That's your angle. So this is the scalar times an angle. In my case, watch this. Remember, this 5 doesn't mean anything. It's irrelevant. This guy is my B. And there is no e to the ax, so therefore a is 0. In other words, you can rewrite this as 5e to the 0x sine of 4x, and then compare it to this formula right here. Right here. So looks to me a is 0. Do you see it? This is a, this is b. So what's the annihilator for 5 times what? Sine of 4x. It is d squared minus 2a times d plus a squared plus b squared. But my a is 0, so I get d squared plus 4 squared, because these middle terms, these guys are 0 because a is 0. I don't have e to the x, I have e to the 0x, you know? So therefore, these guys go to Neverland, so you get d squared from b squared, but my b is this guy, 4, so 4 squared, so my annihilator is d squared plus 16. But that's not it. That's not the final answer now. The final answer is the product. So what is the final answer, you ask? It is d minus 7 to the 4 times d squared plus 16. Does the order matter? No, it doesn't. Okay. Maybe we should do a couple of more, and then I will show you how to solve these guys next Tuesday, right? Let me just at least find the annihilators for 5 more minutes. Okay, what about this guy? Can you guys tell from this table what would be the annihilator for e to the x times sine of 2x? So remember what I have. I have e to the, what did I say? X sine of 2x. What would be the annihilator using formula number 2? Anyone?
D square minus 2d
Yes.
plus 1
Squared. Yes.
plus 4.
Exactly. Did you hear? A is 1. B is 2. So go back and form this operator. As she said it correctly, it is my first annihilator. It is d squared minus 2ad, which is minus 1 times d. Where am I? Plus a squared plus b squared. There. Answer, d squared minus 2d plus 5. There. 1 squared plus 2 squared is 5. What would be the annihilator for this guy? Remember, 3 doesn't mean anything. What would be the annihilator for cosine of 2x from the same formula? So I have cosine of, what did I say, 2x. What would be the annihilator using formula number 2 for cosine of 2x? I can't, oh, plus 4, not minus 4, Louis, plus 4, it's plus. Anytime you square something, you get what? Plus. Even if this guy was negative, you still get plus. Okay, so good. So Q2 is, what did you say? D squared plus 2 squared, which is D squared plus 4. But the final answer, which I'm going to box it, is d squared plus 4 times d squared minus 2d plus 5. If you have some time this weekend and you got nothing better to do, Apply this operator to this function and see if you get 0. Okay, what about this guy? This guy is sine of just x. I would say this is a single term, so I only need one annihilator. And I would say the answer is D. Okay, well, this guy has an x square in it. So now I have to use formula number 3, because formula number 3 has cosine, sine, e to the ax, and also x to the k. So, looks to me, it looks like this guy. Which guy? Oh, which guy? It looks like, let's say it looks like this. Looks like this. What is my problem? X squared sine of x. Or I can write this as x squared e to the 0x sine of 1x. Comparing this guy to this formula looks like my k is 2, my a is 0, my b is 1. Right? So now follow this annihilator. D squared minus 2ad plus a squared plus b squared, except now you have to raise it to the power of k plus 1. Remember, these guys have a factors of x, these guys don't. So what would it be? It would be d squared, what? These guys go to Neverland because a is 0, is that right? Plus what? 1 squared to the power of what? What was my k? K was 2, 2 plus 1, so that's d squared plus 1 to the power of 3. That's my final answer. Okay, here's the last one. What is the annihilator for cosine square of x? Do we have any cosine square anywhere? I don't see any cosine square or sine square. I see sine and cosine in formulas 2 and 3. No sign of a square of sine or cosine. So what should I do after I panic? The table doesn't apply because it doesn't have any sine square or cosine square in it. So what should I do? Yes, any idea? Can you tell us the answer so we can go home? Meaning go to the living room? What should I do? There is no square anywhere on my annihilator table. They all have single powers. Any suggestions? Yes?
Treat each one as a separate
What do you
term.
mean? Like write this as cosine, cosine?
Yeah.
I can't do that. This is one single term. Power reduction? No. How? How do you, Koa, how do you reduce power of this guy? What do you do to reduce the power to 1? What do you do? Because Koa says in chat, power reduction. Okay. How would I reduce the power of 2? All right. The answer is we use this identity. Remember double angle identity? Yes. Thank you. Thank you, Koa. Appreciate. So now this is 2 terms. 1/2 plus 1/2 cosine of 2x. There you go. So I need annihilator for 1/2. Annihilator for what? This guy. Then I multiply the answers and that would give me the final answer. What is the annihilator for a constant? What operator do I apply to 1/2 to get 0?
D.
D. times annihilator for this guy, d squared plus 4, final answer. So if you have sine is square, cosine is square, reduce it to the power of 1, as Koa correctly mentioned, by using identities, then find the annihilator for each of these. Next time, we will see how to solve equations via annihilator. Is this the only way? No, but this is a really nice way to do it. The only problem is it only works for exponential functions, polynomials, and sine and cosine. If you have, God forbid, like natural log, annihilator doesn't work. So why do I say let's learn these, forget about natural log or tan inverse? Because these are the type of functions you'll be dealing with engineering classes. In engineering classes, the functions either will be exponential or sine and cosine. You will never ever have natural log of x as your external force. So why bother? So let's concentrate on these. And for these guys, you can use annihilator. For some of us who are math majors and you have like natural log of x, then annihilator doesn't apply. So we have to use variation of parameters. And if you like, I can show it to you. If you don't, more power to you. This is good enough. It satisfies the requirement of the class. With that, guys, have a great night. If there is any question, I'll stick around for a few minutes. If not, have a good night. And thank you so much for participating. I appreciate and stay safe. Have a great weekend. Thank you, guys.
How should we do the homework on Pearson for 4.4 without knowing how to get the general solution?
Let's see. The homework is due this Sunday. Skip that. I will delete 4.4 problems if I remember tonight.
And 4.5?
Don't worry about that either.
Okay, thank you.
You're welcome.
All right, have a good night.
You too. Take care.